Okay, so we're going to be solving linear equations today. So linear equation is an equation that has an x. Quadratic would be x squared. So we're going to start with number one. Notice that variables are on both sides. So the first step would be to move our variable to one side. It does not matter what side to move your variable to. So that can be up to you. I like to always move it to the side that will make my x positive. So I'm going to subtract 5x on both sides of the equation. So when I do that, 9x minus 5x would give me 4x minus 13 equals, those 5x's cancel, and then I'm left with just 57 on that right side. Okay, so next step, we're trying to isolate x, which means get it by itself. So the next step would be to add 13 to both sides of the equation. So I'm left with 4x equals 70. And then the last step, we're going to get rid of the 4 by dividing it on both sides. Whatever you did one side of the equation, and you need to do the same to the other. Okay, so we're left with x equals, and then we have a fraction. Notice 70 divided by 4 is not going to give us a whole number. I want you to keep your answers in fraction form, so reduce it. So 2 will go into both. So that would be 35 over 2. Box in your answer. To check your solution on a linear equation, you can just plug that back into the original equation and it should be true. So that left side should equal the right side. Okay, so now let's look at number 2. So number 2, notice that we have parentheses. We need to get rid of those parentheses in order to find what x equals. So in order to do that, we're going to have to distribute. So using the distributive property, which means we'll multiply 5 times 3x, which would be 15x. 5 times a negative 18, which would give us a negative 90. Equals, now, some are wanting to do 30 minus 4 before they distribute, but remember PEMDAS, parentheses comes first, so we need to get rid of those before we can subtract. So I'm going to bring down 30, and then make sure you look at that sign in front of the 4. It's negative, so when I'm distributing, I'm going to take it with it. So that would give us negative 24x, and that will become positive because a negative 4 times a negative 9 is a positive 36. After we use the distributive property, we need to look to see if there's any like terms that we can combine on each side. So notice on the left side, we're not able to combine these, but notice on the right side, we can combine 30 plus 36. Now, we're not going to do the opposite there because they're on the same side of the equation. So we're just going to combine like terms. So I'm going to rewrite 15x minus 90. I'm going to bring down my negative 24x. And then I'm going to combine 30 plus 36, which would give us a positive 66. So now notice that our equation looks very similar to what we had on number 1. We have variables on both sides. So my next step will be to move our variable to one side. Again, it doesn't matter what side you move it to. I'm going to add 24x to both sides. It cancels there. So when we add 15x plus 24x, we get 39x minus 90 equals 66. Trying to get x by itself, so next step would be to move this 90, so I'm going to add it to both sides. We're left with 39x equals 156. Okay, so then we're going to divide by the 39 on both sides. So when you divide 156 divided by 39, you get 4. So x equals 4. Make sure you're writing x equals, just 4. Okay, let's take a look at number 3. Notice again we have parentheses, so we're going to distribute. So when we distribute, we get 4x minus 12 equals, this negative 18, and then negative 2 times a negative 8x would be a positive 16x. So always pay close attention to your signs in front of each term. Okay, so variables on both sides, that's going to be my next step. So I'm going to subtract 4x to both sides. I'm left with negative 12 equals negative 18 plus 12x. Notice this time my x is on the right side of the equation, but it doesn't really matter. So I'm trying to get it by itself. So I'm going to move this negative 18 by adding it to both sides, and we're left with 6 equals 12x. And then that last step, we're going to divide by 12. Now, notice here, 6 is the smaller number and it's on top. You should end up with a fraction here. The answer is not 2. The answer is 1/2. So x equals 1/2. Again, to check it, you can plug that back into the original equation, plug it in for x, and then that left side of the equation should be equal to the right side. So always check your solution. Okay, so looking at this last one here, number 4, notice that we have a fraction with a variable here. If that confuses you, just cover up that denominator there, and it's just like having a 4x minus 6 equals 14. So if we have that equation, the first step would be to add 6. Same thing here, even if you have a fraction, you're going to get rid of that constant, which means the number without the variable. So I'm going to add 6 to both sides. We're left with 4 over 5x equals 14 plus 6, which is 20. Okay, so then we're going to get rid of the fraction. You can do it in 2 steps or 1 step. If you're doing it in 2 steps, you can get rid of the 5 by multiplying on both sides, and then you would have to, excuse me, divide by 4. Or you can get rid of it all at once by multiplying by the reciprocal, which means you will flip that fraction there. So I'm going to multiply by 5 over 4. Whatever I do to one side, I must do the same thing to the other side of the equation. So I'm multiplying both sides by 5 over 4. Notice these right here just cancel out to a 1x, which is what we wanted. And then here, you are multiplying 2 fractions. You can either multiply the tops and then multiply the bottoms and then reduce it, or reduce it before you multiply. I like to reduce it before I multiply because it makes it a little easier. So multiply, or when you're reducing diagonally. So 4 will go to 25 times, and then you have 5 times 5, which would give you 25. The other way, if you had multiplied the tops, you would have got 100 over 4, which still gives you 25. So x equals 25 on number 4. Again, you can plug that back in and check it.